Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. So, as coincidences go, nothing really is to talk about in terms of any kind of arguments or experiments for the last couple of days. And I've also had a bad back, pinched nerve thing, and happens every few years. I do something. And it's yeah, so I haven't got enough sleep, and it's really not been pleasant. So anyway, there's nothing really to do except go over these arguments over and over until somebody shows up and makes a rational, on the subject, counter argument. And they just won't do that. No one so far can, in any reasonable way, respond to the actual arguments that have been made. That gravity, like all the other forces, frankly, is time dependent. A force needs to act on you because a force, like photons, is usually made up of a bunch of little crap. Okay, and the fact is, the little crap takes time. There's a volume of it over a distance, and it's all moving towards you. And like photons, light takes time to get to you, and you need a certain exposure to collect it. To be suntanned, a certain number of the photons have to hit you. So you have always a time component is necessary for you to collect the photons. Now I'm making the simple argument that gravity basically works exactly the same way. Just like a light bulb behaves the inverse square law in terms of how it exposes you to light. That is, you go 4 times the distance, it's 16 times dimmer, quadratic with distance, because it's spreading in 2 dimensions. The little bits are getting separated from each other in this direction and this direction, which creates a square, and it ends up being twice the amount of space anyway, for half the distance. Anyway, so this is very comparable. So the basic idea is everything sits in space, and whether the force is magnetism, if they're subject to it, that is, if they're a dipole, then they can be affected by magnetism, and it'll just be about how much they're being affected, which side is producing more, the left or the right, or the top and the bottom, or the forward and the back. And really that's all that decides, is that forces really affect you in these 3 dimensions. I guess I could draw that arrow sort of that way. And that's it. It's a 3-dimensional reality, and you can only be going right or left. You can't be going both at the same time. So as force interacts, it constantly balances and rebalances, and everything ends up with a trajectory based on an arbitrary assignment of these 3 dimensions. I mean, up can be this way, and down can be this way, and you can fiddle with the orientation any way you like, and it just always adds up to you have a certain amount of right, then you have 0 left. You have a certain amount of forward, then you have 0 backward. That kind of thing. So everything acquires this thing called movement this way. So you have the classic example, Galilean example. And he figured this out not by dropping things, but by rolling things down a ramp. And any scale of ramp would produce the same results, which was 1 unit of distance traveled in 1 unit of time, and then 3 units of distance traveled in the next unit of time. And it always continues that proportion. So anything that's rolling, or anything acquiring gravitational force, so rolling is basically friction, and it just duplicates the same relationship that exists here, which is 1 unit of distance gets you 1 velocity, 4 units of distance get you just 2 velocity. Okay, it doesn't produce the 4, because essentially this first activity, this, is exactly the same as this fall. And both objects at this point would have 9.8 velocity, and they will travel, if it's 1 second, 4.9 meters of distance. and the next 1 second, so this is 1 second of time, and the next 1 second 3 times the distance is covered. So it's 1, 3, 5, 7, 9. That's Galilean. So it's 500-year-old physics. Okay, and it basically demonstrates pretty clearly time-dependent force. Yes, 4 units of distance, but only 2 units of velocity, 2 units of time, and you only weigh twice as much, so twice the weight. That's the reality. And pretty much this alone as an argument kind of proves, that there's really no reason to not say the words, that gravity is a time-dependent force. So this and this, adds up to just rolling something on a flat plane is exactly the same rules. It's Galileo figured that out too. It didn't matter what pitch he gave to his rolling plane wedge, the same result. It's always the same, and each event is always the same. This event, okay, I give this, these are both the same mass, and I give them both, I give this 1 velocity and I give this a 2 velocity, and it's going to do exactly what this does, except it's going to show the energy being dissipated over a length of time and show you the distance, and show you that it's just an illusion that this did 4 times the work. It only did twice the work, and the truth is it's only twice the velocity to start with, and you're going to have the same effect. And even inside of this thing's rolling, the same rule applies. In the first unit of time it does this much, and in the second unit of time it does this 3 times as much. Same thing happens here. It's in reverse. So as it's losing energy, as it's losing velocity, in the first 3/4 of the trip, it'll be the same time, 1 unit of time, same amount of time as this takes, 1 unit of time, and then in this second part will be the same amount of time, and the velocity here will be 1/2 the starting velocity, and the same rules always apply. Everything that rolls does exactly the same thing. And so this essentially happens here. You reach 1 velocity at this point. These 2 events are going to be equal, and this event is going to produce the same amount of degrade or loss of your energy. So if there was 300 watts of heat put into the ground here, there's going to be 300 watts of heat put into the ground here, because this is more pressure, more weight is actually hitting the surface because of the slower velocity. So per foot, more pressure is put on the ground than per foot pressure here because of the increase in the velocity. The force can't act because the object isn't on the surface long enough for the force to get into the surface. So it's just a simple truth that if you roll something over a scale, that there's a speed you can get to where you go faster than the scale can feel the weight. And the faster you go across the scale, once you reach that point, the less and less the scale will deflect, indicating you're weighing less and less. What it's really indicating is that there's less time for this force that's raining down to push down, because only a tiny percentage of the force actually gets to it because of the time. Again, the force is a bunch of stuff, and it has a volume per billionth of a second, but that volume has a distance, a density in time. And if if this is the only time you get, then you're only going to get this much force. You lengthen the time, there's more time for the rain to fall on you. So you need time to get a sunburn, you need time to get wet in the rain. It's all about time. The force is collected through time, and time tells the tale about what energy is. So this leads to a conversation that took place between Leibniz and Newton in 1770s and so forth, somewhere in there, 1670, and just a dispute about whether mv is the nature of energy, motion. The quantity that's conserved, that is the nature of heat or energy, can be measured as just taking a mass and a velocity, and that volume, that product, is the essence of energy, versus Leibniz's notion, which was mv squared, because he actually believed that if you dropped a 1 pound object 4 feet, it would equal dropping a 4 pound object 1 foot. Now that's experimentally incorrect. It doesn't work. Okay, and there's two different ways you can understand it. This is just doubling the velocity. So if I took 4 pounds, and I took another 4 pounds, or 1 pound, frankly, and I just double the velocity, I can produce. Small interruption. So the problem is when you drop things on a scale. Let's say you were going to try to measure the acquired force that something acquires by falling. You have to subtract, which is actually its weight, because if you're going to measure it on a scale, you're going to deflect a spring, for example, the spring's going to deflect from the weight itself. So if I put 1 pound on the scale, it's going to deflect a certain amount just for 1 pound. If I put 4 pounds on the scale, it's going to deflect a certain amount just for the 4 pounds. Then there's the motion, volume part, that creates an impulse. So you have to consider that you have to subtract the weight from the reading on the scale. But you can also just change your scale's orientation, and then you don't have to worry about the gravitational weight because it won't be measurable. So if you have the scale this way and you measure, the weight of an object, 1 velocity versus 2 velocity, you'll find that the 2 velocity weighs twice the weight. Alright. That if you want to double the compression of a spring, you just double the amount of velocity you give an object. Now, I could have pointed out that your standard weight is basically deduced by doing the same experiment, where you just take a mass and see what velocity you need to create its weight, its atomic mass, reading its weight. So if I had 100 pounds, there's a velocity that I can give it where it will weigh, on the spring, 100 pounds. And if I had 50 pounds, likewise. And that motion is 1 mile per hour, or 0.447 meters per second. Now, the true answer might be 0.5 meters per second, but it doesn't really matter, or a little bit less than 1 mile an hour. But who's to say? So anyway, so that's pretty conclusive right there. All of that stuff it adds up to the fact that mv is the reality and mv squared was a mistake. Leibniz was wrong. It doesn't take the same energy to lift 4 pounds 1 foot as it does to lift 1 pound 4 feet. 1 pound 4 feet is easier, twice as easy. So he's just plain wrong. All right, and then this was reinforced. This 1.5 mv squared was reinforced by a French woman, de Charolais, when she and another guy dropped round objects into clay, and they didn't drop them so they would penetrate deeply, creating a hole. They just dented the clay with the round surface. And because the fact is that something with twice the velocity will create 4 times the displacement in the clay. Well, it's because it's not a linear surface. And the deeper you go, the more you're pushing this way instead of pushing this way. The less deep you go, the more you're pushing down. The deeper you go into the clay, the more you're pushing sideways. And it's frankly just easier to move clay sideways than it is to move clay down and then sideways. That's 2 motions. That takes more energy. So it can be simply understood that it's not a good measure of energy. So the 2 foundational axioms of the argument through all the way to the 1800s were both wrong. They were wrong premises. Alright, so I have continually made arguments about how gravity works. So we have a gravitational body. Let's say it's the Earth, and we're only going to talk about going 1 mile, so we can make the Earth flat. for this example, and we're just going to say you're going to start with two different velocities. Okay, one thing, you're going to go from point A to point B, and this distance will be the same distance. It's going to be traveled. You start with an object, let's say 500. So let's say it's a mile, and let's say at 50 miles an hour. If you have an initial velocity of 50, so you're a meteor, and you're coming in with a velocity. If you have an initial velocity of 50, let's just say it takes 10 seconds to get to the Earth. When you get there, after 10 seconds, you're going to gain 9.8 meters per second. So let's just make it rounded off to 100. So you're going to hit the Earth going 150 miles per hour. Well, it's meters per second. So we'll change that to meters per second. So you gained 100 from this distance. This distance produced a 100 increase in your velocity. All right, now if you're going 500 and you travel that 1 mile, you're only going to end up gaining 1 second worth. So instead of 10 seconds in the force, getting pushed by the river, getting hit by the photons, you're only getting hit for 1 second instead of 10 seconds. And so all you're going to get when you hit the Earth, you're going to have your original 500, you don't lose anything, and you're only going to have 10 more. So you have 510. So you're only going to gain 10. So in one case, you gain 100 in velocity. In the other case, you only gain 10. Same masses, same distance. So obviously the distance math won't work. And the time does. So time works in both circumstances. Whether you start with an initial 0, okay, as your velocity, time gives you the right answer. And if you go in with an initial velocity, time still gives you the right answer, where distance doesn't. So if you think distance is the cause, that is, you think traveling each unit of foot is the cause, it doesn't work when you give something a velocity going in, which indicates it isn't the truth. The fact is it just gained 10, and it gained 100 here because of time. It's not about the distance, it's about the time. It's about how much time you were being hit by the bits, okay, that come as a unit of time. It's 9.8 meters per second. It means that you're getting hit by, you could say, 9.8 bits of energy in 1 second. And if you're in it for 2 seconds, then it's going to be 19.6 bits of energy. It's that simple. So this is a conclusive argument. No counter argument provided by anybody. No one demonstrating how anything stated there was incorrect or critically wrong. Factually dubious. Not a single argument, just insults. That's all they can muster are personal attacks and insults. They can't muster actually drawing the experiment as I'm detailing it and showing how I made any mistakes in what I detailed. So this is another example. You have the gravitational body. You're just going to travel from a point A to a point B again. And the simple truth is, if you want to know how much you're going to get bent by the gravity, all you need to know is how much time are you going to spend in this field. This field, okay, it has a positive value. This has more energy than this has. And basically there's a flow heading towards, let's say it was the Earth, heading towards the Earth. And all you're really saying is how much is that river going to push me? How much is that wind going to blow me? And it's only going to matter how fast, how long I'm in it. And the faster I go through it, the field of energy, the less and less and less it has time to act on me. So if I travel slowly, I crash right into the Earth. I travel faster, I still might hit the Earth. I travel a little faster, I get bent. Faster and faster I go, the less and less the force has time to take my motion this way and add motion this way. It can't add the motion this way if I'm not in that field of energy, if the bullets aren't hitting me. These bullets are coming at a period per second, and if I travel through them quickly, I'll get hit by very few. I travel through them slowly, I get hit by a lot. That's a simple truth. It's a simple statement, and it's absolutely true. It's never going to be proven wrong because it's right. And it certainly proves that gravity is a time-dependent force. It's just about how much time you spend in a force field, a field of unequal or diverging forces. That's all that matters. So, I guess I could do one more example, but I just don't know. Well, I'll think about it. I'll consider it. Alright, so yeah, there hasn't been any counter-argument. There won't be. There's no evidence. I defy somebody to link to any experimental evidence debunking or proving otherwise than what I did draw and state that actually does happen in the real world. And, I have made these points about spaceships, and, physicists will admit, doctorates in physics will all admit that, frankly, if I shot 1,000 atoms going 1 mile per hour out this side of the ship, and then I shot one atom, going 1,000 atoms going 1 out this side, 1,000, and I shot one going 1,000 miles per hour this way. It's the same thing. One atom with a very big velocity is the same as thousands of atoms with a very small velocity, because the velocity is held by each one of the objects, and you can't see the little tiny arrows, but if you have a lot of masses, there's a little arrow on each one of them, and if you add up all those arrows, it's the same arrow. It's the same amount of energy. It's the same amount of ability to do work in the universe. MV, momentum, is correct. It gives right answers. It tells you how the spaceship's going to move. If mv squared was true, then it would work here too, because their physics says, mv squared says, momentum says this is equivalent. 1,000, this adds up to, just let's say 1,000, and this adds up to 1,000. 1,000 times 1 times 1,000, same difference. Same amount of energy. And it's true, it works. That's what actually happens. Their theory, this theory about distance mattering and all that crap, that theory says that there's 1,000 joules of energy on this side. Wrong way. My mistake. This is the one going 1,000 miles an hour. So the side with the one atom going 1,000 miles an hour, let's just say it has 1,000 joules. The argument is this only has 1 joule of energy. So it's the same as a watt. They're saying this side of the ship, there's 1,000 watts of energy, heat, let loose. And this side only let loose 1. And the momentum says they're equal. But they say, that as a physical reality, this object will only do 1 joule of work, and this one will do 1,000 joules of work. Alright, and it's completely fallacious, made up. The evidence doesn't say so. There's no reality that says so. So let's also understand this silly concept. And this is silly, It's not just stupid and wrong, and it's not just like inaccurate. It's stupid. Because this says, and this is where you say, well, what are you going to say about physicists? They really don't pay much attention to the details. So they love their math, but they really don't know what a concept is. I mean, frankly, I don't know if one of them could fix a toaster. Well, if anybody used a toaster anymore. I mean, they're not mechanical. And the funny thing is they say that engineers like this crap. For some reason, engineers like this silly mv squared thing. And it says, this is what it says. I mean, I didn't make this up. This is its contention. You go twice the velocity, that is, you go from 10 miles an hour to 20 miles an hour, you'll do 4 times the damage. And it will take you 4 times the fuel to do it. So it's not twice the fuel to go twice as fast. That's what they say. And it gets worse and worse. You want to go 3 times the velocity? It takes 9 times the fuel. 9 times the fuel, they say. and you will do 9 times the damage on impact. All right, and like I said, it just gets worse and worse. 4 is 16 times the fuel. So to go from 10 miles an hour to 40 miles an hour is 16 times. Well, to go 10, you're increasing by, to go 40 miles an hour is 16 times the fuel. 16 times more fuel than just to go 10 miles an hour, to go 40 miles an hour. And that you're going to do 16 times the damage. And then the 5, 25, 25. Again, it just gets worse and worse. And with these preposterously silly concepts, this is where they get this idea that some single electron going half the speed of light could knock down the Empire State Building or something. I mean, they end up with silly notions of something's capacity to do work because of this exponential, this quadratic increase in work, power, and consumption of force, consumption of fuel. And none of this has been demonstrated to be true by a single experiment anywhere. There's no experiment that shows it taking 4 times the fuel to go twice as fast. And there's certainly no experiment showing that if you're going 5 times as fast, you do 25 times the damage to anything. Absolutely no evidence. And what little evidence there is, car crashes, that kind of stuff, momentum rules. Momentum always gives the right answer. You can conserve the momentum. And the fact is, you got no evidence of this quadratic increase in the damage in the collisions. I mean, 4 times the damage is a lot. You really don't need 16 times to understand that it's worse. If you have an accident at 40 miles an hour, it's worse. It's 4 times worse. It's not 16 times worse. Okay. That really should be enough. I mean, it's really deplorable that they have no evidence really supporting the theory. They arrogantly insist everybody must believe, and they must believe without seeing it. They just tell you it's F equals ma. And again, they won't even fess up to the lie. And they keep trying to imply that Newton believed this mv squared when he directly opposed it. I mean, he made statements opposing it, and then he had people argue for him, like Darwin had people arguing evolution for him, who clearly were arguing from Newton's perspective and pointing out that this wasn't truth. And yet people put that in Newton's mouth. And they call themselves scientists, and they call themselves decent people when they lie. And it's an overt lie. I mean, it's a grotesque lie. It was a real controversy between Leibniz. They didn't just argue over who invented calculus. They argued over this. This was important. It wasn't a trivial matter. It's a fundamentally different view of how the universe works. And they shouldn't lie about it. I mean, frankly, they won't even fess up that it's terribly unfair to Newton to say he said it was F equals ma when he clearly said force equals velocity. Force equals momentum. Your momentum will be changed proportional to the force that you're affected by. And it's going to depend on how much time you're in that force. It's going to decide how much force you were impacted by. Alright, so I can, there's nothing else I can do. I can just be an honest player. I make honest arguments. I detail them, explain them, and all they do is talk shit. So nobody will stand up and show some integrity and explain, if you believe I'm wrong, or you know I'm wrong, then you should be able to duplicate what I did and show where I made an error, where I drew something in error. Okay? And if you can't do that, then you should concede the argument, and concede you really have no right to expect people to believe without evidence or even logical consistency. Again, the notion that gravity is a time-dependent force, that theory works no matter what initial velocity an object has. It still gets the right answer, where their work equation, force equals time, distance times work equals force times distance, obviously doesn't work if you have an initial velocity. Alright, so enough said. So till the next time, when I'll probably just keep doing the same thing, right? Been doing it for almost 2 years now. Put the videos in 5-minute chunks. Did everything I can to make for an efficient contest between these two theories, and they just won't participate. The naysayers are just that. They just say nay. They don't argue. They don't provide evidence. Nothing. So, not much I can do. I can only do my part of the argument, which is to be logical and reasonable and rational and explain the actual history, not the lies. It's not again, it's not Newton's theory. They should call themselves Leibnizians. They are not Newtonian, okay? And they should name it by the origin of it. They ought to put that correct label on it. I mean, it's kind of funny that the guy who invented it, they slight him by not mentioning him at all. And probably because his arguments were so bad that they're basically undefendable. He didn't have any evidence. He just believed it, and he asserted it. And that's it. He didn't prove it by showing an example. He just stated a false example as a premise. That's frankly really bad physics. It's really bad science. And it's tragic that almost unanimously you're voting for that bad physics, that bad science. It's disgustingly tragic. It's grotesque.